Alright, so 9.4 looks at linear, quadratic, and exponential functions. And those are the three types of functions that we've learned this year, so we're going to start reviewing. So, what does it mean to be a linear function? Who remembers? It's a line. It's a straight line. Okay, so to be a linear function, it has to be a straight line. Okay, what does it mean then to be a quadratic function? What do those look like? What do they look like?
Oh, the curve.
The curve, right? So it looks like kind of like a U or like an upside down U?
Yeah.
Okay. And what do exponential functions look like? That is what we went over yesterday. Kind of like a hook, yep. So they kind of are flat and then they go up. Really steep. Okay, so those are the three functions we've learned this year. So those are the three functions we're going to look at today. Yep, looks like you. Alright, so these are your notes. You need to write these down. You'll need them for today's assignment and for tomorrow's assignment.
Today I'm going to my dad's. Oh, I ripped it.
I don't have a favorite. Line. So your line should look like this, straight line, either going down or going up. And it is characterized by the constant first differences. Okay, so constant first differences. Quadratic function looks like a U, or if it's flipped upside down, then it looks like an upside down U. And it is characterized by constant second differences. And then our last type of function that we learned in this unit is our exponential function. And it usually starts out flat and ends steep. And it is characterized by a constant multiplier. What? Okay, so we're going to look at two things today. We're going to look at graphs of functions and identify them as linear, quadratic, or exponential. And we're going to look at tables of values and identify them as linear, quadratic, or exponential. Okay, so the first example I'm going to look at is example 1, where it gives us a table of values and we have to graph that to determine what type of function it is. So I'm given the table of values, x is 0, 1, 2, and 3. And I'm given the y values 10, 20, 40, and 80. Okay, so since these numbers are all like really big, I'm going to go by tens on my y-axis. Okay, because that'll make it easier to graph. So for 0 to 10, I'm going to go over 0 and up 1, because 1 is actually 10 on my graph. Then if I go to 1, 1, 20, so over 1 and up 2, because 2 is 20. 2, 40, so over 2, up 40. And 380, so over 3, up 8 to get to 80. Okay, so if I connect those dots to make a line, what type of graph does that look like? Exponential, very good. It looks like my exponential graphs. That is not how you spell that. Exponential. There, that looks a little better. Okay, so let's do one more like that, and then we'll look at tables of values. Okay, so I'm given the table 0, 5, 10, 15, 20 for my x's, and 32, 41, 50, 59, 68 for my y's. So I'm going to need to graph this to figure out what type of function it is. Okay, so since my x's go by 5, 0, 5, 10, 20, I'm going to go by 5s. And since my y's kind of go by 10s, I'm going to go by 10s. Okay, so 0, 32, over 0, up just a little bit more than 3, right? 'Cause 32 is just a little bit bigger than 30. 5, 41, so over 1, because I'm going by 5s, then up to a little bit more than 4. 10, 50, so over 2, up 5. 15, 59, so over 3, up to almost 6. And 20, 68, so over 4, up to almost 7. Very good. So if I connect those points, what type of graph do I get, Fawn? Linear. Very good. Looks like a straight line, so we call straight lines linear functions. Okay, so pretty straightforward on the graphing. It'll give you all of your tables of values, and all you have to do is plot your points to determine what it looks like. So any questions on the graphing part? No. Okay. Second part of what you're going to do today is you're going to take a table of values, and you're going to decide based on the table if it's linear, quadratic, or exponential. And so, in order to be linear, it has to have constant first differences. So if I find my differences, okay, so minus 144. So to get from 400 to 256, I subtract 144. It's not? Okay, so, oh yeah, so 256 to get to 144, what do I subtract for that one? $112. Okay, so are these numbers the same?
No.
No. So then we would say that it's not linear. Let's do one more. Let's do the last one just so that'll help with our quadratic. So what do I do to get from 144 to 64? What, Tana? 80. Yep. So I subtract 80. Okay, so we can obviously see that these aren't the same, so it's not linear, because linear has to have constant first differences. The next thing then that we have to check is quadratic, which has constant second differences. So we take our linear numbers, and we figure out what we do to get from one to the other. So what do we do to get from negative 144 to negative 112? Add 32. My numbers are going up, so add 32. And from negative 112 to negative 80. Okay, so are those the same? Okay, so we know that this function is a quadratic function. If this didn't work, then what's our only other option for a function? Exponential. If linear doesn't work and quadratic doesn't work, then you don't even have to worry about doing the third step. You just know it's exponential because the other two didn't work. Right? Process of elimination. Okay, so let's do that one more time, and then you guys can get started. Minus 3,000. Okay, 2,550. And from 14,450 to 12,282. Do this one on your calculator, guys. Take 14,450 minus 12,282.50 and tell me what you get, because it's going to be like a weird decimal. You're definitely going to have a 0.5 in there somewhere.
The 2, 1, I'm not sure.
Yeah, that looks right. So minus 2,167.50. Okay, so are these the same? No, so we obviously know it's not linear. What do we check next? The second one, which is called quadratic. So we'll check and see if it's quadratic. What do I do to get from negative 3,000 to negative 2,550? Add 450. Okay, and what about from 2,550 to 2,167.50? Well, I'll take 2,550 and subtract 2,167.50 from it. 382.5. Okay, are those the same? Oh, bad. Okay, so we know it's not quadratic, which means our only option left is exponential. Okay, so check linear, check quadratic. If neither one works, you know it's exponential. It is a shorter assignment today because there is some graphing, so 653, 1 through 15.